Take a look at now section 3.3. 3.3 is a section about a concept called intercepts. So I'm going to go to some blank paper and just sort of define what's going on for us. I want to talk about intercepts. An intercept is the point where a graph crosses an axis. An intercept is a point or the point where a graph crosses an axis. So let me be a little more specific about that. Do y'all have time to get that written down? Okay. In our class, we're going to look at two kinds of intercepts. If you were in a really advanced class, there's a possibility that you could look at more than two kinds. But for us, two is plenty. Well, in fact, for most of undergraduate college math, two is plenty. So we'll just look at two. We're going to look at first the x-intercept. If I have a graph, and let's suppose that it looks like this, which is not a line, but that's okay. We're not going to graph any of these, but we might see some of them. Where do you see, or do you see, an x-intercept? Okay, most of y'all are nodding your heads that you see. Do you agree that this is an x-intercept? Yes. And that this is an x-intercept? Yes. Okay. If there was a nice grid here, could you read the ordered pairs that name each one of those? All right, the one on the left, what would the ordered pair be? -2, and the y value is? 0. What would be the ordered pair that names this one? +2, 0. What do those 2 points have in common? Do those 2 points have something that you notice that's the same? The 0. All x-intercepts have as their y-coordinate 0. It should make some sense. If I picked, I'm not going to even put a dot here, but if you just look up at the screen, if I picked this and I said, oh, here's an x-intercept over here, do you agree that the coordinates of the point I'm pointing to right now would be some negative number, 0? And this one would be some positive number, 0. This one would be 0, 0. But no matter what, if you're sitting on the x-axis, your y value is 0. So, an x-intercept, the one thing we know, y equals 0. For all x-intercepts, it is y equals 0. It will look like something, 0, for an x-intercept. Because when you're on the x-axis, your y value is 0. All right, what if I looked at the same picture, but I talk about y-intercepts? Do you see a location on the red graph that you would think is the y-intercept? Okay. Do you agree it is right here? Yes. And I'm going to put some little marks here. if I put those marks on there, what would be the coordinates of the y-intercept? 0, comma, -4. Now, a graph that you're going to see in this, well, there's a class of equations that are graphed, and they typically only have one y-intercept. They might have a bunch of x's, but they usually only have one y. You might see some others in here. I only have one. I only have one right now. Do you agree that if the y-intercept would be up here, it would be 0, comma, some positive number?
Yes.
And if I was at this point, it would be 0, some other positive number. And if it were down here, it would be 0, some negative number, or 0, 0. So for a y-intercept, yes, x will always be 0. The ordered pair will always look like 0, comma, something. And that is our little introduction on the concept of an intercept. And they are very nice points. I say nice. They are helpful because when you draw a graph on a coordinate plane, sometimes you'd like to know, well, where is it crossing those axes? Let me look at those. In some math classes, those have some applications. They don't have a lot of application for us because we're just learning the basics of it right now. And so it's kind of hard for me to tell you, when am I ever going to use this? But believe me, understanding the graphing and the intercepts has a big application in some areas of mathematics. Okay, I'm going back up to the top. Question number 1. It says, identify the intercepts, and it starts out by saying, identify the x-intercepts. I'm reading the question right here. Identify all x-intercepts. Type an ordered pair. Use a comma to separate answers as needed. Okay, so x-intercepts. Back to the picture. Do you see an x-intercept? Yeah. Right here? That's the x-intercept, and the ordered pair is?
-3, 3.
Okay, -3, 0.
What?
Do you go up 3? Nope. That point, okay, that point is -3, and then it stays for 0. So over here in the answer spot, it says to type it as an ordered pair, so it is -3, 0. Pardon? Yes, it does. It asks specifically in this question. If it didn't ask specifically, then it wouldn't matter. Okay. Back here, now I'm supposed to identify all y-intercepts. This is the y-intercept. What's the ordered pair that names that? 0, 3. You don't go right or left to get to it. You simply go up 3. So it is 0, 3. And that's all there is to question number 1. All right. Question number 2. Now, Otis, this is where it is totally up to you. This question, let me get it on the screen. This is question number 2. It says, what are the intercepts? And there is a graph, but it does not ask it in 2 questions. It doesn't say, what are the x-intercepts? What is the y-intercepts? It just says, what are the intercepts? So you can answer this in any order you want. The instructions say, type as an ordered pair, use a comma to separate answers as needed. How many answers am I going to have? How many intercepts do you see?
3.
I see 3. Do them in whatever order you please, but you're going to have to name these. So here's an x-intercept. What's the ordered pair? Okay, if you could see it better, it is the point -4, 0. Now, my personal choice is if I'm doing an x-intercept, I'm going to go ahead and do the next x-intercept. That's just my choice. What ordered pair names this x-intercept?
0,
Is it 0, 4? 4, 0. You always do the x first. What ordered pair names the y-intercept?
0,
-4. So when I would write this answer, here's what mine would look like. And yours might look different. But I would have -4, 0, close parentheses, comma, open parentheses, 4, 0, comma, 0, -4. If you mistype that in any way, MathLab's going to tell you it's wrong. I had a student really frustrated send me an email, this was last semester, and what he or she was doing was leaving out these commas, which seemed to have nothing to do with the mathematics. But remember, MathLab is just a computer program, and all it can do is look for certain things that it's told you to have there. If you miss a comma, then it just doesn't have the right picture. All right. Problem number 3. I think we're going to skip doing this one. It just says, what are the intercepts? And there are 4 of them. It doesn't matter what order you list them, but there's 1, 2, 3 x-intercepts and a y-intercept. So I'm going to skip that one. Number 4. Good luck.
1,
Okay, it says to identify the intercepts. Do you see 2 x-intercepts and 2 y-intercepts? Okay, when you do this one, and this is number 4, for some reason, it went back to separating them. And it asks you to first identify the x-intercepts and secondly identify the y-intercepts. So you're going to see that in MathLab, that sometimes you do them in any order and sometimes a specific order. Now, I want to get to number 5 because now we're going to use this concept. We know what intercepts are, and we're going to use it to graph a line, but you know what? We've already done this, and that's why this turns out to be, I hope, a lesson that you think is easy. We've already done this because I pushed for it. It says, graph the linear equation by finding and plotting its intercepts. This is how I encourage you to do it, and this should look super familiar. Draw a T-chart. And you're sitting there thinking, T-chart? That's what we did in 3.1. This is intercept stuff. Yes, it is intercept stuff. Intercepts are just points. They're special points, but they're just points. And guess what? If x is 0, you're going to get the y-intercept. And if y is 0, you're going to get the x-intercept. Remember how I was pushing for those zeros?
Yep.
I knew what lesson was coming up next. And so I hoped this is nothing more than a T-chart, but you are absolutely required to use 0 and 0. When you take a test over this, when it says to find, and I have it highlighted, intercepts, then you have to make the T-chart with zeros. Now, I'm going to show you something. Well, you can do this if you want. Let's start by doing it traditionally. X is 0. And I have x minus y is 3. 0 minus y is 3. That means that negative y is 3. Am I finished?
No.
No. Divide by negative 1. And y is negative 3. Now I'm going to let y be 0. I have, whoops, that looks like a funny letter. All right, if y is 0, x minus 0 is equal to 3. That's gone. X is 3?
Yep.
All right, negative 3 and that one's 3. Whoops. All right, those of you in class, are y'all able to see all the work? You know where everything came from? All right, when you graph, I'm not going to spend nearly as much time with graphing because you've been doing it, but starting at 0, 0, 0, negative 3 is down here, and 3, 0 is here, and you would grab your straight edge. Well, you don't have to worry about it, but I should have grabbed my straight edge, but I just drew it freehand. Let's look at another one. The next problem is negative x plus 3y is 6. Because it says to use, intercepts, here, it says to use the intercepts. It does say something there, and I know that those of you in the back of the classroom can't read that, but I'm going to tell you what it says. It says, use the graphing tool to graph the equation. Use the intercepts when drawing the line. If only one intercept exists, use it and another point. Now, right now you might be wondering, how could only one intercept exist for a line? And we'll talk about how that could happen in just a second. It will just become apparent when it does. All right, what do? I start out with T-chart, x, y, and what do I put in it? 0 for x and 0 for y. Now, the traditional way to do this is to write out all the steps that I've been writing. But I want to show you, and I learned this from my son. I had not ever done it this way, but his teacher had taught him to do it this way. And I'm not at all above stealing good ideas. So I like to borrow those. If x is 0, this is what he did. Now, I can't put my finger over something because it's projected electronically. But if I put this circle here, and suppose that I'm saying if x is 0, then this goes away. Agreed? So if this goes away, so ignore it, you have 3y equals 6. What is y? 2. Yes, because you're going to divide by the 3. Okay, so his idea is, okay, so he covers up one variable because it has become 0, and he takes care of the rest of the problem. So when he covers this one up, negative x is 6, divide by negative 1, and we get negative 6.
Oh, but you got it.
I did. I liked seeing something new. All right, so then I would plot these 2 points. And I'm not going to enlarge it in class. I'm just going to jump in here. 0, 2 is right here. And negative 6, 0 is right here. Use a straight edge if you're, oh, that was terrible. That's why you're supposed to use a straight edge. There we go. Close. All right. Number 7. It says to graph this equation using intercepts, and the equation is y equals negative 5x. Use the graphing tool, and if only one intercept exists, find another point. Okay, so x, y, 0, 0. All right. How about I use the Stephen method? That's my son. All right, if x is 0, do you agree that this side becomes 0? So it just says y is 0. If x is 0, y is 0. Done. Okay. What if y is 0? Okay, if y is 0, I got a 0 there now. Wouldn't you have to divide negative 5 into that 0? And you would get 0. I looked at both of these, and by the way, if you want to do this and follow through, if you don't like the cover-up method, and you've got y is equal to 0. That was one of them. And if y is 0, you have 0 is equal to negative 5x, divide by negative 5. I'm showing what we talked about. All right, so no matter which way I did it, I got 0, 0. This is the case where you only have one intercept? 0, 0. It is right here. The only way that you can have only one intercept is if the line goes through the origin. That's where it's crossing both the x and the y. And I can't draw a line from there because I don't know if it ought to go like this or like this or like this. I don't have any idea. So I have to get another point. So I'll just let x be 1 because I think I said earlier 0 was my favorite number and 1 is second. And I'm doing this part in red. If I have x, whoops, I don't quite know what I did there. Okay. If I have x is 1 and y equals -5 times 1, y is -5. When you get 0, 0 for the x-intercept and 0, 0 for the y-intercept, that means you don't have enough information. You need to go in and find another point. So y is -5. So it is the point 1, -5. Oops. In MATLAB, it would have already drawn the line for you, but there's my line. Okay. We've got a couple more to look at. Oh, number 8 is special. Let's see if we remember. It is the line x equals 6. You should not have to do any work. X equals 6, special line. What does it cut through? X-axis at 6. So I know that that's the first point I'm going to click. Up and down, so pick any other point that is straight above that or straight below that. Whoops. Close enough. Special line, x equals 6. Number 9. It says y plus 2 equals 0. Well, it's special because it only has one variable in it. It has a y, but it's not in the right form. I need to subtract 2 from both sides, and I have y is equal to -2. This line cuts through which axis at -2? The y-axis. And pick any other point on that horizontal line. And it should look something like that. Number 10. It says x minus 9 equals 0. Do you agree that it is special? And is it in the form it needs to be in? No. I'm going to need to add 9 to both sides. I get x is 9. Which axis does it cut through? The x-axis at 9. And you'll just pick one other point above it or below it. The special lines, I hope you will find to be the easiest ones to graph. The special lines will only have one kind of intercept because they don't cut through both of them. All right, any questions? Are we okay? All right, please be working on MATLAB and try to get through 3.3 before you meet class again.